Welcome, everyone. Welcome to the seventh installment of Proto Talks. I'm your host, Matt Morgan, President Protogetic, the protective design marketplace. Before we get started, I'd like to acknowledge our sponsor, Norshield Security Architectural Products, a leading manufacturer of doors and windows for the security industry. Today's 70-minute talk features one of the most important topics in our field. And that has become thwarting active shooter events. I'd like everybody to know that we've been waiting for some time to have our keynote speaker return and do round two of this topic on crisis architecture. And certainly the timing seems a bit more poignant given the events recently. Unfortunately, it seems like it's a problem that's getting worse. And at the same time, I believe our industry can be taking a leadership role by sharing our expertise to create actual solutions to mitigate and possibly prevent these continuing tragedies. To that end, I am proud to welcome back Dr. David Gartenstein-Ross, one of the foremost experts on this topic. Dr. Gartenstein-Ross is the founder and chief executive of Valens Global. He is a well-known scholar of counterterrorism and sub-state violence, who is also the lead drafter in the U.S. Department of Homeland Security's 2019 document, Strategic Frameworks for Countering Terrorism and Targeted Violence. This document recognized the important shifts in domestic extremism in the landscape of domestic extremism that have become more evident over the years. Dr. Gartenstein-Ross is also the author or volume editor of more than 25 books and monographs, including Bin Laden's Legacy, Why We're Still Losing the War on Terror. David, welcome to Proto Talks. Welcome back. It's good to see you.
Thank you, Matt. It's great to join you again and to be able to delve deeper into this topic, though obviously the drivers of this conversation are rather somber ones.
Certainly. I'm going to let you take it away and just go ahead and take control.
Thank you. The title of today's talk is Crisis Architecture 202, Design, Retrofit, and Implementation. As Matt alluded to, I delivered a proto talk about a year ago in which I made the basic case for crisis architecture, which is a mode and paradigm for architecture designed to provide greater survivability in the case of mass attacks. As I'll explain in greater detail in today's proto talk, crisis architecture is also designed to preserve the form, function, and beauty of buildings and the built environment, even while creating greater safety from mass attacks. A year ago, at the time of my last talk, we were partway through reopening that was occurring in the wake of the COVID-19 pandemic. Mass attacks had temporarily declined because mass gatherings had steeply declined. Some other security professionals I know, for whatever reason, did not anticipate the resurgence in mass attacks that we as a nation are now experiencing. So in light of a number of recent tragic mass attacks, my friends at Protogetic decided that this concept was even more relevant today than it was a year ago. That's why they invited me back for this follow-on presentation. So today we're going to move from the basics of crisis architecture, the 101, if you will, to a more technical discussion of all the principles of crisis architecture, how they fit with and reinforce one another, and how buildings can be retrofitted to comport with crisis architecture principles. So we have all seen the recent mass attacks, including most significantly Uvalde. I don't need to dwell on these horrific attacks. I do, however, want to explain how crisis architecture fits into the picture as a part of the solution set. the fundamental idea of crisis architecture is that the built environment should be a part of how we address the challenge of mass attacks. In some past attacks, the buildings themselves stood in the way of those who were trying to escape from violence. In some past attacks, the built environment helped the killers. A good example is the notorious Sandy Hook Elementary School attack, in which over 20 people were killed, most of them elementary school students. In that attack, the teachers executed perfectly on a mass attacker drill that the school had undertaken. They had their classes sheltering in place. The problem was that the door to the classrooms wouldn't lock from the inside. They only locked from the outside. So classes were sheltering in place without even a lock on the door to protect them. This is an example of where if you change the architecture, you change the outcome of the attack. So the fundamental idea of crisis architecture is that if we change how we think about our architecture, we can save lives. Crisis architecture incorporates tactical, psychological, and technological measures. The question naturally arises, but doesn't this lead to jarring, securitized architecture that emphasizes the threats faced? The answer is that crisis architecture is actually the opposite of what I call securitized architecture. Crisis architecture is designed to preserve a building's function and aesthetics. Securitized architecture can be jarring, foreboding. If you think of high schools with barbed wire fences and metal detectors at every entrance, at some point, they don't look like schools at all. They look like fortresses or like prisons. Crisis architecture is an alternative to buildings overloaded with security features. It recognizes that architecture that is in subtle ways designed to increase survivability can look natural. It is meant to allow buildings to be beautiful, yet it's also designed to use the physical layout to save lives if disaster strikes. Another point that I often hear when people are skeptical of the idea of crisis architecture is that we should focus instead on gun control or addressing mental health. The answer to this objection is that there's no trade-off, whatever your position on these other investments. If you think about it, in my opinion, it is somewhat cruel to say that we're not going to make the built environment work to make our young people safer, to make others safer in the absence of gun control. Gun control represents a collective action problem. One would push at it at the municipality, at the state or federal level. And even then, there might be constitutional constraints that prevent the implementation of whatever gun control regime you're seeking. In contrast, we are empowered to make our schools and to make our public places safer, even in the absence of other actions taken by municipalities, by states, by the federal government. Moreover, our architecture has long been used to address social problems. Perhaps the best known modern architectural paradigm designed to address social challenges is the widely adopted crime prevention through environmental design, which is meant to harness the built environment to reduce fear and reduce criminal activity. So with the basic case for crisis architecture made, I now want to take a deeper dive into crisis architecture's 8 core principles. I think last time around I explained about 3 of them, and the focus was on making the basic case that the built environment should be used to increase safety in the case of mass attackers. So turning to the first of the 8 principles, it is to enable creation of distance. Structures should allow people to rapidly move from one area to another, which is critical in the first moments of an attack. Most mass attacks are over very quickly. To allow people to flee from the attacker, there should be numerous connecting hallways between parts of a building and multiple staircases between floors, which produces short transit times. An example of this principle is the Pentagon. It's the world's largest office building. How long does it take to walk between any 2 places in the Pentagon? On average, only 7 minutes. This is because it has numerous internal corridors and stairwells. Creation of distance allows potential victims to quickly flee. Why is this important? Let's look at the attack in Orlando's Pulse nightclub on June 12, 2016. At 2:02 a.m., an attacker entered and began shooting. Patrons were trapped. By the time the incident was over, 1 in 3 people in the club had been killed or wounded. 49 lives were lost. But 60 or 70 people managed to escape toward the beginning of the attack when a bouncer moved through the gunfire to open a locked side door. This act, which saved lives, would not have been as necessary if Pulse's design enabled more rapid creation of distance. The second principle is multiple exits. You probably don't know who this man is, but he saved at least 10 lives. Liviu Librescu was an engineering professor at Virginia Tech. He was a Jewish man of Romanian descent. Dr. Librescu survived the Holocaust as a child and survived Romania's communist regime as an adult, but did not survive gun violence in America. In April 2007, a disgruntled senior at Virginia Tech, where Dr. Librescu taught, went on a shooting rampage. He tried to enter Dr. Librescu's classroom. The 76-year-old Librescu held the door closed. He yelled for his students to escape. In doing so, he bought them vital time. 10 escaped through the window. Finally, though, bullets ripped through the door and took Dr. Librescu's life, as well as the lives of 2 students. Escape from the classroom could have been easier and faster. The crisis architecture principle that applies here is this: buildings should have more exits. This includes not only standard exits, but non-standard ones, pop-out windows, emergency rope ladders for upper stories. The third principle of crisis architecture is incorporate angles. In the 6 minutes of the infamous high school shooting in Parkland, Florida, the gunman killed 17 people and wounded another 17, all without ever leaving the main hallway of the school. He never entered a classroom because he didn't need to. From the main hallway, he could see and engage every single victim due to the visibility he had into the classrooms. Long straight halls where people have no place to avoid being seen are dangerous in an attack. So are rooms where most of the floor area can be seen from the door. Angles can limit a shooter's line of sight. Halls with turns and visually appealing barriers can reduce the number of targets that a shooter has. Speaking of barriers, this brings us to the next principle of crisis architecture, Provide adequate cover and concealment. Cover can stop bullets, while concealment can stop a person from being seen. During a December 2015 attack in San Bernardino, at least one victim was hit by bullets passing through non-resistant walls. A second was hit when bullets ripped through a non-ballistic glass door. Let's look at the crisis architecture principles that can address this kind of situation. For cover, designers can use hardened structural features and design elements. They can use walls built of bullet-resistant materials or ballistic doors and windows. Large plants or furnishings can provide concealment. Another idea for concealment: smoke emitters. They can be triggered by a gunshot or a person pressing an alarm. This is already in place in some American schools. Fifth, enable rapid hardening. In a mass attack, most casualties are inflicted in a short period of time, as I already mentioned. A design that allows rapid hardening can alleviate this. Features that can rapidly harden a structure include push-button deadbolts, window coverings that drop when an alarm is triggered, and internal ballistic doors like existing fire doors that can be electronically closed. These measures can be controlled individually, such as by teachers who can push a button in their classrooms, or else centrally by a school administrator or a security official. Rapid hardening allows a building to maintain its full form and function until defense against an aggressor becomes necessary. When it does, the attacker can be quickly isolated from potential targets. As I noted earlier, at Sandy Hook Elementary School in Newtown, Connecticut, classrooms could not be locked from the inside. They could be locked only by using keys from the hallway side of the door. The teachers had no ability to harden their rooms, and the consequences were devastating. Had those teachers been able to lock down the rooms when they heard the gunfire, or had an administrator been able to do this centrally, lives likely would have been saved. The sixth principle is to implement human-centered design concepts. Often the victims of mass attacker incidents are untrained and unprepared. These incidents are always chaotic and confusing, and people react instinctively. Innate fight, flight, or freeze responses tend to drive behavior. Human-centered design can help by increasing understanding of the most likely course of action people will take. Buildings using the crisis architecture paradigm should be designed to work with human instincts to maximize safety in a moment of excessive adrenaline and minimum rational thought. There are many creative ways to do this, including the architectural lines of a building being used to focus people toward exits, or else lighting exits in ways that draw attention and using color and shape to make that cover obvious. A Royal Society study of neurobiological mechanisms found that in stressful situations, most people tend to fall back on primary freeze, fight, flight tendencies and have great difficulty controlling their actions. Observations of numerous mass shootings reinforce that in nearly every case, potential victims' natural instincts take over. A common reaction is to hide under or behind the closest piece of furniture or to run haphazardly without a real objective other than escape. By utilizing one natural process in the human brain, that is the ability to observe natural patterns and environmental indicators to influence a second, that is fight, flight, or freeze, design can enhance the instinctive human desire to survive an attack. The seventh principle is that training and design need to be mutually supporting. When people receive attack response training, such as schools, the training and architecture should be mutually supported. For example, if an organization's active shooter protocol is to shelter in place, the spaces where they are supposed to do so need to be built to withstand attempted entry. The doors should have secure locks that can be activated from inside rooms, and the walls should be able to stop bullets. Sandy Hook is an example I gave before. It provides a tragic example of the need for training and design to be mutually supporting. Teachers had trained on lockdown procedures, and indeed, the window in the door leading to one of the rooms where numerous casualties were inflicted was still covered by dark paper from a lockdown drill. As I mentioned, the teachers had executed on their drills perfectly. Their efforts were not supported by the building design. If the school had a system where a single button could be pushed that dropped a window covering and deadbolted the door, the lockdown procedures would have been more effective. So the eighth and final principle that I want to discuss before we turn to a short discussion of retrofitting buildings is integrate systems to increase the situational awareness of first responders. The efficiency of law enforcement response to an active aggressor situation can be degraded if law enforcement lacks sound information about the location of the attacker, the location and condition of victims, or the layout of the building. Builders should install systems that decrease the amount of time it takes for first responders to gain situational awareness, thus decreasing the reaction time. These could include internal gunshot detection technology to relay the position of gunfire, systems to allow victims to report the location of the shooter, and small lights, for example, green or red, near doors and external windows to indicate if someone in the room is wounded. Building administrators could also give first responders temporary access to security cameras. Any law enforcement reaction will be less effective if the police struggle to understand what is happening before, during, and after they arrive. At Marjorie Stoneman Douglas High School in Parkland, Florida, police were not authorized to access the school's surveillance camera system until they were on site. They also didn't know that the footage they were seeing in the security office was on a delay. The shooter left the scene while officers were still viewing what they believed to be live footage of him inside the building. This misinformation hindered law enforcement, victim rescue, and medical response. Increasing the information available to first responders will increase their effectiveness. One of the primary advantages of crisis architecture is that it creates a comprehensive and systemic security-focused design. For that reason, the optimal manner in which to integrate these principles is to utilize as many of them as possible in either initial or renovation plans. Employing an integrated set of principles when retrofitting buildings to enhance security provides numerous advantages over implementing independent security features in an ad hoc fashion. The design can be comprehensive and systemic. Rather than picking and choosing among independent solutions designed to fill individual security gaps, a structure strategically retrofitted with security in mind can integrate its security measures together. Furthermore, the use of integrated principles maximizes a manager's ability to provide security while maintaining the space's intended functionality. Retrofitting in an integrated, systemic manner also helps maintain the form of the architecture as it was envisioned. Crisis architecture as a paradigm can help guide the refurbishment of public and private structures. But not all of us, obviously, are in a position where we can undertake comprehensive retrofitting. So if we're retrofitting selectively, my own assessment is that it can work and increase survivability, even if you don't have the opportunity for a comprehensive cut at it. There's utility to only employing, one or a few principles. If the principles are treated like a basic menu where one or two items are selected, the structure will have an overall lower level of security. But you can adjust for this and use a partial retrofit to make you safer, just so long as the principles selected fit together and connect to a terminal positive strategic outcome. Generally speaking, there are three major outcomes that can occur in the case of a mass attacker. Those three positive outcomes are, number one, fight, give the people some ability to fight back. Number two, flee, get them out of the building. Or number three, shelter in place. The problems occur when not everything fits together. A good example, again, is the Sandy Hook attack, which I talked about, where there is a clear plan in place to shelter in place, but design did not support that option. Ultimately, picking different principles needs to connect them to some terminal outcome, which will result in people reaching safety. Moreover, one of the things we're now experimenting with is looking at crisis architecture in a cost-limited way. In other words, a building might have $5,000 to retrofit or $10,000 or whatever. How do you get the most out of that money? That's something that we've been looking into and experimenting with, because my view is that for a lot of crisis architecture principles, the cost doesn't have to be high. That's particularly important for places like our schools, which are often on extremely limited budgets. I would now like to conclude this presentation before moving on to Brandon and moving on to our broader discussion. And I'll note my contact details are there. I frequently am in touch with people to talk about crisis architecture principles and other matters. For all of you, I would encourage you to reach out to me or to connect to me via LinkedIn. But my key point at the end is that the principles of crisis architecture can make a difference. If tragedy strikes, they can save lives. I've now made the case across two proto-talks that we should focus on the physical spaces where attacks occur. The idea of crisis architecture, of realizing that the physical layout of our buildings and public spaces can help to protect us, should resonate widely. I've spoken about the more technical details of this talk of implementing crisis architecture. It isn't hard to do. We spend money now on building security. The idea of crisis architecture is that we can make this security more strategic, and defensive ideas can better fit together. Thank you.
Wow, thank you, David. That was really informative and very interesting. We're going to move over to our Q&A and our discussion now. Without further delay, let me introduce our second expert for today's discussion. We're fortunate to be joined by Mr. Brandon Keel, a senior security advisor for Protection Engineering Consultants. Brandon is a certified protection professional, and prior to PEC, he led the physical security consulting business for Burns & McDonnell. He is also the former police chief of Braemar, Missouri, and Brandon has led or participated in the publication and update of the IAHSS Basic, Advanced, and Supervisor training manuals. He also participated in the U.S. Army Corps' Unified Facility Criteria documents, and most appropriate to today, the ongoing development of the ASTM standards for protecting against armed aggressors in educational institutions. Welcome, Brandon. Welcome to Proto-Talks. It's great to have you.
It's great to be here. Thanks, Matt. It's sometimes can be a little frustrating that we have this discussion sometimes more often than we probably would like to. But it's great that we're looking at things from a architectural standpoint as opposed to a response standpoint, which has really been the traditional approach.
Yeah, agreed. And it's good to have you. And let me actually start off with the first question, and I'm going to direct it at you, Brendan. You know, we just heard David talking about crisis architecture. Maybe you can bring the two of you a little bit more into focus and tell us how your work with ASTM standards is kind of relating to that.
Well, for starters, thank you for that question. That's a great question. The most interesting thing about this is that traditionally we have looked at these types of crisis events, these incidents, as either a mental health problem or as a response problem where we're needing to encourage or incorporate the ability for response. But we haven't, to a great extent over the decades, looked at it from how can we adapt the built environment to make these events more survivable. And so the approach of the subcommittee or the task force that's working on this within ASTM is to try to build a set of guidelines or recommendations that assist in the design process all the way back at the planning stage, so that those things can find their way into the design without then having a material retrofit cost the way that David was just describing.
Right. Okay, great. David, did you want to add anything to that at all?
No, I think that's a wonderful answer. I was moving on to think about some of the excellent questions that some of the other attendees here had already shot to us. So if it's okay, maybe I'll launch right into Abdul Amin's question, which is the first one asked.
Yeah, I saw that. That's a good one. In fact, I think, we'll just agree. Why don't you just field the questions and I'll try to organize them for you as we go. Yeah.
Wonderful.
Okay.
So Abdul Amin had two questions together. The first one is, how do you reconcile the requirement to allow quick egress for fire emergencies, for example, to the proposal to have shelter in place, which actively limits existing or exiting? And the second question is about the possibility of misusing these tools, like children locking a classroom as a practical joke, for example. So with respect to the first question about the need for rapid egress, I personally have not seen a shelter in place example where it would stand in the way of rapid egress if done right. There's generally two kinds of shelter in place that I see. One is a designated shelter in place area. For example, there are some offices that we've worked with that will have a single room where people are supposed to shelter in place, where that room is a relatively safe one. And if so, people could go into the room and rapidly harden it. In a typical situation, like a fire situation, the existence of that room won't stand in the way of rapid egress. So I'd say the two kinds of ways that shelter in place generally occur are, number one, by being able to lock it. And a lock is a feature that in typical situations is not going to stand in the way of rapid egress. Obviously it will if the door is locked, but that's a typical feature of locks. Or the second is rapid hardening. And rapid hardening will only be deployed in a crisis situation. As to the second question, which is a great one, about the possibility of misusing these tools, I actually think that possibility is the reason why for Sandy Hook, the doors couldn't lock from the inside. They were concerned that if the doors could lock, then students might lock the doors. Most security features in that way are double-edged in certain ways. But in this case, I think that there's a couple of ways to make that particular risk of practical jokes, et cetera, a minimal risk. The first way is you always can override a locked door with a key. It might take a little while. You might have to get a custodian there or the like. But generally speaking, the ability to lock a door or harden a classroom, in my opinion, outweighs the risk of a practical joke or a temporarily locked door. The second way that you can deal with it, which is a little bit more expensive, but also easier to override, is having a mechanical override. So if you have basically rapid hardening where a door will drop down, for example, from a centralized push button, that push button can just reverse that rapid hardening. Something like that would not be as simple for students to play with in terms of a practical joke, because it would be centrally controlled, for example, from the administrator's office or the like.
Okay. David, we've got another one coming in here, and I think I'll throw this over to Brandon to start with. What is your advice when aiding schools in obtaining funding for these crisis architecture upgrades and renovations? I think you both can answer that at will, but Brandon?
Yeah, I appreciate this question as well. One of the difficulties I think we always face, especially in the public building type of environment, is that there's always going to be a how do we best spend these funds? And when you've already got a built environment and you have a multitude of different approaches that you could take with the spend of that dollar, what is going to have the most dramatic impact? And I think traditionally, I think the easy to understand and the very palatable decision making is the easiest. I think that makes that happen. I think David spoke to it just a little while ago, and when he talked about securitization of the site, that's why you see high schools across America, elementary schools across America that went up with barbed wire fencing and guard checkpoints and things like this. And I am not speaking necessarily against any of those features, as much as I'm saying is that when you're weighing how to spend the $5 that you have, do you put it towards that, which is immediately recognizable by the parents as an improvement, or do you put it towards crisis architectural, which may actually have a more impactful long-term impact than maybe something that's a little less visible instantaneously. And so that's a great question. I'd say if I was going to answer that with anything less than the 3 minutes I think I just took in explaining my understanding of the question, I'd say that one incident anywhere typically makes the justification for most spend, especially in a retrofit situation, as long as that spend is done well. As a practitioner, I'm typically against spending money on single solution type, whether it's a product or a service. If it only solves one problem, I typically will recommend clients spend money on something that will solve 2 or 3 or 4, or has the potential to solve 2 or 3 or 4. So when you're looking at it from a crisis architectural standpoint, what it does is it allows you to solve multiple standpoints or multiple potential future problems, as opposed to just focusing on one, whether it's improving a door lock, which solves you one problem, or may continue to solve you multiple problems in the future. So,
okay.
So I think Braden's answer is excellent. I just want to add to it a little bit, which is to say that for implementation, either in whole or in part, of crisis architecture principles, schools don't necessarily need to obtain additional funding. Looking across kind of a range of schools, and I've talked to a lot of people in the education industry to get a sense of this, they typically have, even if it's almost nothing, they have some budget for security. Even if it's ad hoc and they have, say, a custodian who used to be in the US Army who's concerned about security, they'll have a little bit of resources that they can devote to it. So the first thing I'd look to before, I think that asking for more resources is important, to be super clear. But I also think that even if you're not getting more resources, your budget is strapped, because most schools are in that position, I would flip the question around a little bit and say, can I look at this through a different lens where I'm maximizing the safety that we get from the budget that we currently have? That's why I mentioned how we're now looking at kind of micro implementation of crisis architecture. So for example, if it's something like, you have kind of a room, which is a relatively safe room, is there a way to combine, say, concealment, number one, with human-centered design, number two? That could be as simple as moving different objects in the school around to allow an egress route into the safe room. But it's thinking about strategically, if an attack occurs, how do I maximize the resources that I have to increase survivability. So I want to throw that out there because sometimes schools and others see it as a barrier where unless I have the resources, I can't do this. And one of the things that we've been looking to do is figure out how can someone do crisis architecture on the cheap. Obviously, if you don't have money, you're not going to get maximum survivability. But since we tragically have to look into this question, I think it's worth making asking the question of, given existing resources, how do I make the most of them? How do I best increase survivability?
Yeah, that's really a great point. And especially when you get into what can I do with the existing environment that I have now, and with no dollars, and moving things around to make things more survivable.
Yeah, I think that's an interesting
looking at the architectural environment is
exactly, yeah,
a fantastic perspective change from how do we keep bad guys out, so to speak.
Yep. Okay. Next question is from Dennis Montoya. He'd like to hear a little bit more about retrofitting walls and windows with anti-ballistic materials. David, you want to go for that?
Sure. The big thing I'll say is that this is one of the relatively expensive retrofits that would occur. So a lot of schools would not be able to do this, but bulletproof glass is relatively expensive. There's other classroom features. So there's different ways in which a variety of vendors have looked to provide anti-ballistic materials. So one that I was looking into recently is a dry erase board that's also anti-ballistic. It's a 6.5 foot high by 4 foot wide board. And just for context, on sale, it costs about $2,500. Full price is around $5,000. And that gives you a sense of the kind of price that might be involved. So to me, this is one of the last things I would look to. What it can create is a true safe room, right? Like a true safe room where even if you have an attacker on the outside try to shoot in the door, you'll be able to shelter there for a while and the attacker won't be able to get in.
All right.
The fact is, in most school shootings, you don't get to a point where something like that is happening. Like in most school shootings, there will be an attacker and they'll be able to fire into a classroom unimpeded, or there'll be no barrier for them. So to me, something like that is high end. And certainly for certain offices that are high risk environments, it ends up being a really good idea. But for a school, I would say that my own focus would be concentrating on how do we just impede or slow down the attacker? Because it seems like in most school shootings, something like that is effective, and it'll cause the attacker to go look for something else to do in the moment.
Yeah, and that's a great answer. Interestingly enough, as you heard in the presentation just a few minutes ago, David talked about both cover and concealment. And while cover might be, this is where resistance is there and the round won't penetrate to cause that damage or that injury or death. Concealment can be, in many cases, a lot of times, just as safe. It's not as good, but certainly just as safe. If the shooter can't perceive a target, then they're unlikely to take that shot. Or if they take that shot, they're unlikely to strike the area that they're trying to. So when you are in a limited funds environment, concentrating more on concealment than nothing is certainly when you're looking at it from a planning perspective, that's a great idea. And that doesn't have to involve necessarily ballistic rated walls or even the products that are out there. I think he mentioned one of them, and there are a multitude of manufacturers out there that do sell these ballistically rated products. One of the difficulties with ballistic rated material is that it's rated for a specific velocity on a specific round at a specific distance. And it's not guaranteed to protect against anything else. So then, okay, you've made the decision to put ballistic something up. What are you protecting against? You could protect against something and something else could sail right on through it. And you don't know what that aggressor is going to choose when it's target and action time. And so So from that perspective, I jump right back into, if you've got to spend money that's going to get the most impact, concealment over nothing. And a lot of times, cover isn't necessarily going to be in budget, but as he said, that's one of the last boxes to check.
Okay, great. Thank you. Next question is from Jack Schinder. Can you comment on the effect of attack-resistant door assemblies designed to slow down an active shooter versus bullet-resistant door assemblies?
Brandon, do you want to take that one first?
Can you repeat the question? Because it cut out for just a moment.
Sure. Can you comment on the effect of the attack-resistant door assemblies designed to slow down an active shooter versus bullet-resistant door assemblies?
I would comment in just the nature of the fact that of underscoring the point I think I just made a moment ago with regard to the way that certification happens with resistance. There are a variety of different levels. There's actually a variety of different testing methods. ASTM is one of the testing methods to determine a ballistic resistance rating. But there are other guides that produce similar results with different names. But the reality of it is you're faced with, what do I protect against? And something that's hardened against difficult entrance, basically trying to deny access or delay that egress of the assailant, is intentionally designed to cause a delay of X period of time. Whether it's designed to make a 30-second delay happen or a 1 minute and 30-second delay happen, and that's got to do with what types of hinges are used, how it's mounted to the frame, how it is considered, or how the structure around it is considered. And conflicting that against many organizations, when I've seen them add a ballistic rating to the doors, are not adding it to the associated structure nearby, up to and including the window that's right next to the door. And I've even been in projects where we've had to call attention to the fact that they had a ballistic rated door basically encased in drywall, and in
Right.
And I mean, not to make fun of anybody's design choices, but the reality of it is that sometimes these things really have to be informed from a planning perspective, and there does need to be a reality injected into the cost versus benefit. And so that would be the comment, and I'd certainly welcome anything that David would want to add to that as well.
No, Brandon, I think that's an excellent answer. I just underscore the point that Brandon made about the ballistic door encased in drywall, which to me is a good example of a point that I always make in this context. That we spend money on security, and to me it's a tragedy when money is spent, but thought seems not to have been given to how it fits into an overall outcome.
Right.
Like, to me, that's just pure wasted money. Similarly, you'll sometimes see security features that are just not linked to any terminal outcome. There's maybe, places that are just explicitly designed to provide cover or concealment, but it's cover or concealment that doesn't lead anywhere, right? You need it to lead to a terminal outcome. So this to me is why crisis architecture is important. The fundamental point it's making is think strategically, think about how any security feature connects to other features and connects to a terminal outcome. And this is why professionals are important, because they can point to simple problems like that you have a ballistic door encased in drywall, and that encasing actually defeats the effectiveness that you expect the ballistic door to have. With that, I want to fold into Kai Kirk's question.
Yep.
Is there any relationship, complementary or conflicting, between crisis architecture and design for ADA? Generally speaking, I think there's more a complementarity than anything else, in that design for ADA is going to have certain characteristics that come with it. Design for ADA, for example, often means that outside a building, there will be kind of a long sloped walkway. That actually provides a very good opportunity for both cover and concealment around kind of the sloped walkways leading up to doors. If you think about it, like ADA and providing accessibility also provides a little bit of opportunity to provide security features around that accessibility. So it also becomes, an egress point or something else where you can provide defenses around there. That's the main point I would make. The one area of potential, though I think not real conflict, is around provision of angles. But I think that that can easily be overcome. The area where there could potentially be conflict is that too narrow of passageways could conflict with certain accessibility provisions of ADA. But I think that it's not hard to get around that. You don't need angles to be particularly narrow to make them effective.
Yeah, I would agree and build upon that answer. I would just say, just to bring it down to ground level, I would say that, I don't really see this relationship any different than the relationship between fire egress and ADA. They have to be complementary, because the reality of it is that, fire egress has to take into account the ability to get everyone out of that building if there's a fire. Crisis architecture that is also incorporating the same concept, only based on a non-fire incident, based on an intentional incident. I don't think those two things are necessarily going to have to be in conflict, and in most cases are going to be complementary. So just the same way that that egress modeling happens with fire, egress modeling in the crisis architectural sense might be to eliminate those types of choke points or anything else, in the incident scenario.
Right. All right.
And
David, you want to add something?
oh no, we were going to go the exact same place. I think we were going to both go to Holly Stone's comment. And Holly,
That's right. That's right.
She was my co-panelist the last time we did a crisis architecture talk, and so it's great to see her here. And she writes that she is always a huge fan of complete perimeter protection, but it seems to me that this might be the one place where it might make sense to harden the door and not the walls, because the aggressor may concentrate on the door. And Kirk Ferguson also writes in the comments to agree with that. And I agree with both of them that in the context of school shootings in particular, I would concentrate on the door and not the walls for a variety of reasons. You're going to get the most bang for your buck there. To be clear, we've focused it on schools because that's where we've seen some of the most tragic recent occurrences. But there's a variety of institutions to which crisis architecture 202 would apply. So in certain other cases, I would have a different perspective, but like applied to schools, I agree with this. The area where I have a different perspective is I've worked with some clients where they have concerns about targeted assassinations. When that's your concern, you absolutely have to focus on the wall and not the door, because it means it's not a shooter who is focusing on targets of opportunity, but instead is out to kill a particular individual. In cases like that, you do want the perimeter protection, but that's going to be geared to very specific threats and specific reasons why those are perceived. Whereas for general mass shooters and school shooters in particular, I think Holly's comment is dead on and also important, because our focus here is for schools is how do you maximize security at a minimum of cost? Right.
Yeah. I think the only point that I want to, and this is really as an add-on to what David just said, the reality of, and we have centered a lot on schools, but the reality of it is that more than 80% of the armed aggressors, incidents that have occurred, at least as of the last analysis report that was released by the three-letter agencies that do that, had full access to the space where they were in. And so sometimes, outside the exception that he just cited, sometimes the idea that hardening the door is going to cause some extra level of protection, as opposed to providing additional routes of escape, providing additional areas of concealment or cover, providing essentially, when you throw away most of them and just concentrate on the door, you may be misunderstanding the reality that the person that could perpetrate that next activity does already have access to the door. And so I don't want to take away from the concept of improving the protection that's afforded to that portal, as much as I want to also call out the reality that they may already be inside. So don't negate your attention to providing additional means of escape, or providing cover and concealment, or any of the other, making sure that your angles are there so that you're providing the ability for people to be outside the view of a potential targeter, et cetera.
Okay. All right. Another question coming in. This is from Ben. You have focused on examples where the hardware failed to stop an attacker. What standards govern the required hardware, glazing, and door construction to resist an active shooter?
Brandon, would you like to take first crack at this one?
Yep.
Yes, I can just start out saying that, I think the industry, the architecture engineering industry in large part for generations has really been, as it's time to look at a new building or a retrofit for a building, has been almost a checklist approach. Like, what do you need? Owner, what do you need? Let me get a list of the things that we need to make sure that are included and incorporated into this building. And then the next step of that is how do we make that space fit? And then how do we make it code compliant? So the short answer is there are not presently a great deal of standards that require, is certainly not specific enough that say you must use XP41 type glazing on your windows. There is ballistic rated or projectile rated film. But a lot of these concepts that we've been talking about today are not dissimilar when you look at it from the planning stage, not dissimilar to the same approach that's taken from weather protection for a building that's going to be in an earthquake zone or a tornado zone, or for that matter, any other type of threat, whether it's a fire inside or anything else. So I do anticipate more and more attention being given in the codes other than the current NFPA and some guidelines documents that are out presently. Even the ASTM task force that's working now for educational institutions, it's going to be a guideline. It's not going to be a standard, most likely. It's in development. But the reason for that is because it's such a varied application to the environment that it really has to be looked at from a planning perspective.
Okay. David, anything to add?
No, I think that's a wonderful answer. And I was going to move on to Chelsea Medina's question.
Yep.
Which is a wonderful question. I wanted to know how it would address how potential victims are aware to interact with the crisis architecture without potential aggressors knowing the usage. There have been a number of school shooters, including Parkland, in which the shooter knew the measures in place, including, for example, a shooter pulling an alarm and people evacuating, making them easily targeted, despite an emergency system being in place. And so I was, while listening to Brandon's excellent answer to the last question, I was pondering Chelsea's question. And I think the answer is we have to assume that the aggressor will know these measures. Because in so many of these attacks, the aggressors themselves have been insiders. So I was, and you have to make the response, to use a term from Nassim Nicholas Taleb, you have to make the response anti-fragile to the knowledge of an aggressor. For me, I was analogizing it in my head to chess, a game that I love, right? Like in chess, a good move is one where you're not hoping that your opponent won't see it, right? Like a good move strengthens your position, even if your opponent knows exactly what you're doing. And I think of crisis architecture in the same way. And so what Chelsea is referring to, like where the shooter knows the measures and tries to exploit those measures, those are measures that are double-edged. And so when I'm talking about crisis architecture or helping people to conceptualize what they might do to increase safety, I'll always talk about different measures that are double-edged. So here's a good example of a double-edged measure. Bars on windows. Bars on windows can keep thieves out. They can keep an attacker from coming in, but they then prevent the window from being used as a point of egress in case someone is trapped there. Having an evacuation procedure where you pull an alarm and everyone runs out a predictable point of egress, that's double-edged. Just like a security checkpoint is double-edged, right? Running out of a single point of egress is double-edged because if someone knows the point of egress, they can stand outside and shoot. A checkpoint is double-edged, especially if you're trying to protect against a bomb, because the attacker can just detonate the bomb right outside that checkpoint. And we saw that used in an airport attack in Russia several years ago, where the bomber attacked right outside the checkpoint. And the checkpoint was designed to find bombers, but the bomber instead used it as a way to get people massed and then attack them. So I'd say that you always need to be aware of any measure that's double-edged, and sometimes when it is double-edged, such that a knowledgeable insider could exploit it, then maybe that's a measure that you should simply avoid. But good measures like shelter-in-place measures, et cetera, they're not effective because they surprise the attacker. Rather, they're effective because they maximize survivability. And that ultimately is what I would go for in such situations.
Yeah, I think I agree with that a lot. And you just cited the Russia airport bombing, and I would also say, there was an exact example of the everybody egressing after the alarm was pulled. That happened in Kentucky, where a fire alarm was pulled. Everybody marched out to the yellow spots on the playground, and there was a shooter on the hill. This was about a decade or a little over that ago, but nevertheless, this is the genesis of questions like this. Well, what if the bad guy or gal knows what our procedures are? And that is not something that you can ever discount. But the reality of it is that you have to build in the hardenability of your idea, the way that you just described. If it will sustain itself, no matter if somebody knows the procedure or not, you're really on to a good program or a good plan. And providing oblique angles, or providing the opportunity for cover and concealment, multiple egress routes. These are examples of ways that whether they have the idea or not of the program in that location, the aggressor is not going to be able to overcome those features.
Yep. All right. And last question, I'll put out to the both of you. Have you heard any discussion of adding this type of information to the P100? Brandon, you want to start?
I would just simply say there's always discussion of adding it to not just the P100, but all sorts of different, whether it's NFPA or ASTM or ANSI or any other standards trying to make something. But a lot of those discussions really are responsive. And I want to caveat, and I think this was touched on early in the discussion today, that this was planned before this resurgence of frequent incidents occurred. So this webinar isn't a response to this. This Proto Talk is not a response to that, but it is timely, unfortunately. And so the more planning you can do, the less response you have to do, or recovery you have to do later on. And so from that perspective, I would say yes, and I would encourage additional conversations about getting it into more standards.
And David?
No, I think that's a wonderful response, and a good one to end on. Since you said that was the last question, I really just wanted to thank Protogetic for hosting this talk. I wanted to thank Brandon for his truly excellent contributions. Brandon, I hope we'll get a chance to work together on some of these issues, and that I think we could do a lot together to increase public safety against this threat. And for everyone who took part in the discussion, I think this is a really important discussion, and it's heartening to see the amount of interest that people have in thinking creatively and strategically about how we can create a safer built environment.
I couldn't agree more. And David, thank you for your time and your contribution to today's discussion and presentation. That will be it. I'll start wrapping it up here. David, Brandon, thank you again. And we'd also like to thank very much our sponsor, NorShield, one more time. Please go ahead and check out their products on Protogetic. We have a little questionnaire that popped up. We'd love you all to participate in it so we can get a sense of what other products, or presentations you'd like to see. And for now, I will say goodbye. Again, thank you, David. Thank you, Brandon. Thank you, everyone, for participating. We'll see you next time at the next Proto Talk.
Thank you.